To begin this chapter, we will discuss the network architectural components at a very high level. First, we discuss the concept of the enterprise campus. In the examples below, I'm going to use Albertus Magnus, but please understand that the term enterprise campus refers to a specific area where there's enterprise computing done. It's not related to academics necessarily at all. So please, let's make that distinction first of all. The enterprise campus represents a distinct entity in the network, and I think that's a good way to look at it. So from the buildings on the enterprise campus, we might have an access layer, which is the layer that allows users and day-to-day workers access to the local area network. Tying that together, we have the distribution layer, which is really a backbone layer, and we discussed what a backbone network was, but it's a backbone network layer that connects all the different LANs together within the organization. Attached to this backbone layer, we have the core layer backbone, which connects with the wide area networks and with general internet access to provide outside connectivity to other enterprise campuses as well as to the general internet. And this diagram is provided below. Also, the core layer campus backbone network ties everything in with the data center, which is very, very important, as you all know. So this is your typical layout of an enterprise campus. I said I was going to tie this in with Albertus Magnus. So let's look at the Albertus campus in New Haven, Connecticut. And then let's look at the Albertus Magnus campus in West Hartford, Connecticut. So we have different buildings here that tie different local area networks together for local access. We have distribution layers, which are the higher level switches and networking connections that tie us to our data center, which our data center and our core layer backbone network, they are separate here. They are on different floors. I'm not going to go into that, but all those elements exist in the Albertus Magnus campus. And we have another campus in West Hartford, which I've never been to. I'm not sure how it's set up, but it's a good example of the different types of network architectural components that exist. Thanks. The next term we're going to discuss, needs analysis, stems right from project management. Why is the network needed? Performance issues may exist. You may be dealing with a merged organization where standardization needs to occur. You may be dealing with a growing organization where standardization needs to occur. Or hardware may just need replacement. As you all know, computer technology advances very quickly and hardware gets old and hardware becomes less reliable. You also need to ask what users and what applications must be supported. And it's important to know that goals differ depending on the network component. So LANs and backbone networks are typically built with organizational ownership and are often built with excess capacity. Remember I told you to look at the net mask at Albertus Magnus? Think about how many different computers they're able to create for their network. Way more than they'll ever use, probably. And that's an example of the excess capacity. Between the New Haven campus and the West Hartford campus, they require a wide area network, or a WAN. And as we know, WANs rely more on leased equipment, and circuits are typically designed at or near capacity with organization because there's much more cost involved. You know, for Albertus locally to set up a net mask of 255.255.40.0, I believe it is. They have plenty of expandability there, whereas that's more space than, like I said, they're ever going to use, but that comes free to them. There's no cost there. However, when you're leasing equipment and you're leasing bandwidth, cost is going to be involved. So the goals can differ depending on the network component. Thanks. When doing the needs analysis, baselines have to be considered. Baselines create metrics of current operations to compare design requirements against. If you don't have a good solid understanding of where your current operations are and what speeds it has, you have no idea of what you want to achieve and how much better. You can't just say, I want it to be faster. That's not good enough. So baselines may include sequence of operations, specific calculation of processing times, the amount of work volume that's able to be done, existing costs, and existing user and management needs. So you need to baseline all that and make sure that what you're trying to do can be measured. And that's the concept of baselines. Next comes the technology design phase. Most of this stuff should be pretty much common sense, so I'll go through it relatively quickly here. Some of the items in the technology design phase, the development of a physical network design for a set of possible designs. So basically this is where you sketch out, you design what you want the network design to be set up like, and you come up with a couple alternatives. These designs include clients, servers, circuits, networking devices such as routers, gateways, access points, switches, and so on. So it's usually a pretty complex diagram and design that you come up with. You need to start this up very high level and end up with a very low level design. Some considerations may include what hardware needs to be purchased and how much hardware needs to be purchased. And you need to look into the possibility of upgrading some existing hardware. So lots and lots of considerations with technology design. Finally, we discuss cost assessment. Cost assessment involves the financial analysis of various technology design alternatives, which we sort of discussed in the previous slide. It's a complex process that requires the analysis of many factors. Circuit costs, this is especially important in wide area networks because there's leasing involved. Internetworking devices such as switches and routers. You want to have a good switch, you want to have a good router, but you maybe can't necessarily afford the Cisco stuff, so that's a concern. Software costs, licensing of operating systems, and application software and middleware costs as well. A lot of times you need to pay a support contract on a yearly basis for much of the stuff. That needs to be considered. You need to consider network management and maintenance costs. And you need to discuss operations costs. And like I touched on earlier, the wide area network and internet circuits are usually leased and don't come for free. Thanks. So I've quickly covered network design in this chapter. I also did want to make mention of the PMBOK guide, which stands for the Project Management Book of Knowledge. Anybody interested in a career in project management who have good organizational skills might want to consider taking a look at this here from the PMI organization. Just wanted to throw that out there. Thanks.